Welcome back, my friends and other fellow hackers. It's great to see you guys. Today I'm doing prototype pollution. But first, I gotta shout someone out. Let's find someone. I found a good one. Let's shout out Icon Devco. He said, I don't even know what this is. Woo! That's what I'm talking about. I don't either, but you know what? I'm going with the flow. You know what? Fuck it. Play the intro again. Let's go. Alright, enough of my shenanigans. Today I'm doing prototype pollution. What is this room? It is an overview of JavaScript vulnerabilities. Why did I choose this? Very simple. I suck at JavaScript and I need to get better. If you folks haven't been doing the advent of 2025 and try hack me, I highly recommend you guys get on that shit. I don't know if it's free. You might maybe have to be a subscriber of Try Hack Me. If you're not, you should subscribe. Try Hack Me is great. But there is a challenge in the advent of 2025. Specifically on day 1, there's a side quest. And the first flag was incredibly easy to obtain. But the second flag has me stumped. I'm trapped in the asylum and I don't know the psych ward key. So there's a section, it's a bunch of JavaScript, and for some reason I'm starting to think that JavaScript's just going to become this very popular language, if it's not already. But websites love using JavaScript, so I need to start learning some JavaScript, and especially some exploits. So I'm gonna read this little story here and start busting out some of these rooms. It looks like we're doing cross-site scripting, some property injection, denial of service. I can't really say I have any plans to do denial of service, but you know, good to know. Automation and mitigation. So let's run it back here. Let me get my story voice out. In the thrilling world of cybersecurity, where hackers and pen testers roam searching for vulnerabilities, there's an evolving concept known as prototype pollution. This allows bad actors to manipulate and exploit the inner workings of JavaScript applications and enables attackers to gain access to sensitive data and application backend. That's crazy. While prototype pollution is most commonly discussed in the context of JavaScript, the concept can apply to any system that uses a similar prototype-based inheritance model. However, JavaScript's widespread use, particularly in web development and its flexible and dynamic object model, make prototype pollution or a more prominent and relevant concern in this language. In contrast, class-based inheritance languages like Java or C++ have a different model of inheritance, where classes, blueprints for objects, are typically static, and altering a class at runtime to affect all its instances is not a common practice or straightforward task. So to give you my background on JavaScript, I don't know any JavaScript. If you asked me to do a hello world in JavaScript, I couldn't tell you how to do it. I am familiar with Java. I am a little bit familiar with C++. I know some Python. JavaScript, though, very not familiar. In fact, I don't even know what this inheritance model is, this prototype-based inheritance model. So I'm going to quickly just skim through this just to see what I could understand. Inheritance refers to passing down characteristics from parent to child so that a new piece of code can reuse and build upon the features of an existing one. That sounds pretty simple. JavaScript implements inheritance by using objects. Each object has an internal link to another object called its prototype. That prototype object has a prototype of its own, and so on until an object is reached with null as its prototype. By definition, null has no prototype and acts as the final link in the prototype chain. Totally makes sense. JavaScript is a bit confusing for developers experienced in class-based languages like Java or C++, as it is dynamic and does not have static types. While this confusion is often considered to be one of JavaScript's weaknesses, the prototypal inheritance model itself is, in fact, more powerful than the classic model. It is, for example, fairly trivial to build a classic model on top of a prototypal model, which is how classes are implemented. Right, so proto sets the prototype. Okay. A1, B2, is this how you okay, that's how you define the variables, and const O, is O a function? Oh, O dot prototype, oh, so I did like O dot A, I would get 1, and O dot B, I'd get 2. Oh, prototype, oh, what in the world? Maybe I should have read the previous line. There are several ways to specify the prototype of an object, which are listed in a later section. For now, we'll use the proto syntax. It's worth noting that proto syntax is different from the object.accessor. In an object literal like A1, B2, proto C, the value C, which has to be either no or another object, will become the prototype of the object represented by the literal, while the other keys like A and B will become the own properties of the object. This syntax reads very naturally, since prototype is just an internal property of the object. So O prototype has properties B, C. Okay, so the prototype is actually this. Finally, O prototype is no. Oh, I missed this one. O prototype is an object prototype. This one makes the most sense to me, right? O.A. Easy. 1. O.B. 2. Clearly. O.C. Okay, I mean, that still makes sense, but what is this prototype supposed to do? And O.D is undefined because obviously we don't have a D. So what is this prototype meant to do? Okay, now we have D.5. Console O.D is 5. What are the advantages of doing this? Is this just showing me inheritance? Does it inherit all of these properties? Is that what it's telling me? Like, for example, D also has all these properties. JavaScript does not have methods in the form that the class-based languages define them. In JavaScript, any function can be added to an object in the form of a property. An inherited function acts just as any other property, including property shadowing as shown above. I got some nice cold water. Dude, delicious. Oh. Okay, parent method returns this value plus 1. Okay, that makes sense. So it's inheriting all of this. Okay, that totally makes sense then. I'm following pretty clearly at this point. So child.method now. Wait, what? Console.log parent.method. Okay, obviously calling this, and it's doing return this value, which is value 2. 1. Return this dot value. Child proto parent. Oh, okay. So this is the parent right here. So parent is 3, and it's just calling. Oh, no. Parent is actually 2, but when you call the method, it adds 1 to it. I understand. And child is calling parent, and parent is just by naturally 2. And then child.method is calling this again, so +1. Child value equals 4. Oh. Since there's now a value for child, it takes that value instead. Bruh. What? This is... So we got an array here. Return this value. I feel like I got sidetracked, but let's just keep going here. Woo, if you guys don't know, it's day 73. Run the intro back again. Let's go. Woo! Okay, geez, I need to stop running the intro. But yeah, it's day 73. We're cooking. Let's do an essential recap here and see if my mind gets blown up. I need to get my notes out. Okay, so before we jump into the advanced stuff like prototype pollution, let's first understand the basics. Think of objects as building blocks that hold information. Inheritance is like passing down traits from one object to another. Makes total sense, to be honest. Like, just the user has all these inherited traits. Functions are like tools that can be used alone or as part of these objects. Lastly, classes in JavaScript are like blueprints that help us make similar things easily. Okay? So, objects are like containers that... sorry, making some notes. Objects are like containers that can hold different pieces of information. Cool. Imagine a social network profile as an object. Okay, and you get all these properties for the user. Okay, makes sense to me. Here, the user is an object with properties such as name, age, and followers, as well as date of birth. These properties store specific information about the user. To practically test it, open Chrome in the attached VM. Once the browser is opened, right-click and select Inspect, and then select Console, which will open the following window. Please copy the above code and paste it into the console. It will create the user object for you. Now you can access the properties of the object using console.log as shown below. Great, I also figured out how to do hello world. Console.log, quotations, hello world. Alright, I'm up here now, so we can look at my big old Can I make this bigger? I can make this bigger. Ooh. Alright, so we got my user. We got good old Bend over here. Age 100, followers 1337. If I hit the classic console.log user, it just outputs that. Now I gotta do, of course, the classic. I gotta do my hello world here. Oh my god, I'm a JavaScript mastermind. Play the intro. No, I'm kidding. We're not gonna play the intro again. Okay, so it was just telling me that, so now it's going to define classes, and I have no understanding at all of classes for JavaScript. So, in JavaScript, classes are like blueprints that help create multiple objects with similar structures and behaviors. Staying with our social network example, we could use a class to define a general user and a content creator. We could use a class to define a general user and a content creator. I just read the same thing twice. Classes provide a convenient way to organize and instantiate objects with shared characteristics. So we got the class, we got this constructor thing, name, age, follower, date of birth. Oh, okay. Class content creator provider extends user profile. What's different? Name, age, followers, date of birth, content and posts. So it just added content and post. Now, did I need to add these variables since it's doing the extend? That's what I don't know. Because I feel like if it's extending this, why JavaScript is all about inheritance. Why do I need to add those I don't know. Maybe I should just keep reading. Super. What in the world is a super? Refers to the parent class and access its constructor properties or methods. Oh, it calls the parent name, right? No, I'm a little confused. Okay, wait. Return super.greet and hello from child. Okay, so super.greet, the super is telling it to do it from hello from parent. Okay, that's makes more sense. So super calls the parent. Okay. Makes sense. Let's just copy these shenanigans. Okay. Now, the user class includes the date of birth as part of its properties, and the content creator profile class inherits the property. When creating instances of these classes, we can provide the date of birth and other details. As you can see, including the date of birth enhances the user profiles with additional information. So we got Bend over here. What is a let? Do I really have to make these variables? I'm just not gonna make the variables. I don't see how it's gonna. I understand it. I don't know what type is a let. Is this like this changing variable? Is that just what you use to declare a variable? Are scoped to the block of code. Duh. I mean, aren't all variables scoped to the block of code? Okay. Whatever. I'm just gonna assume it's a local variable because that's what it seems like. It's yeah. Okay, where am I at here? In JavaScript, every object is linked to a prototype object, and these prototypes form a chain, commonly referred to as the prototype chain. The prototype serves as a template or blueprint for objects. When you create an object using a constructor function or class, JavaScript automatically sets up a link between the object and its prototype. Okay, let's see. So we got user prototype equals greet function, return hello this name. Okay. How interesting. So this is totally relying on these other functions. How cool. Okay. Okay. User construction function function user prototype. Okay, all that stuff. Let user equals object dot create user prototype. Oh, okay. So you have to create. Does this simply just. Oh, does this become another property of this function? So I'm like, for example, I'm sure I could call different properties of like console.log user dot name, right? Would I be able to call it like that? So this turns into like user prototype? Is that what? Oh, user profile prototype. And what does he do? Regular user dot create. Oh, it gives it the function. It gives it this. Oh. Okay. It allows you to be able to do that function. I don't know why my brain was so slow with that. Okay. All right. Classes and prototypes in JavaScript are two ways to achieve a similar goal. They definitely look very similar. But I'm trying to see if I can find a way to differentiate them. Like, obviously, a class is like the way they describe it is blueprints. So you're defining all these, and a prototype is based on inheritance. So these are part of classes. Imagine you're building models of cars in your room. Using classes is like having a detailed blueprint or set of instructions for each car model you want to develop. You follow the blueprint exactly to create each car, and all cars made from the exact blueprint are guaranteed to have the same features and behaviors. Classes in JavaScript work similarly. They provide a clear, structured way to create objects that share the same properties and methods, making them easy to understand and use. On the other hand, prototypes are like having a basic car model, then customizing it by adding or modifying features directly on the car itself. With prototypes, you start with a single object and then add behaviors to it by linking it to a prototype object that already had those behaviors. Objects created this way are linked through the prototype chain, allowing them to inherit behaviors from other objects. This method is more dynamic and flexible, but can be hard to manage and understand in a structured approach of classes. I feel like I would more than likely see classes in the real world than I would see these prototypes. I think prototype might be more like freestyle type of code, more personal. At least that's what I feel like, but just a general observation, really, without having used this or really have a clientele that use JavaScript. In JavaScript, inheritance allows one object to inherit properties from another, creating a hierarchy of related objects. Continuing with our social network example, let's consider a more specific profile for a content creator. This new object can inherit properties from the general user profile, like name and followers, and add particular properties, such as content and posts. Cool? So now we're just... Okay, so wait. Inherits properties from the user using object.create user. Oh. Oh. Oh, okay. And this is a prototype, right? Or is this just explaining inheritance? JavaScript supports both classes and prototype-based inheritance. Prototype-based inheritance in JavaScript, every object has a prototype, and when you create a new object, you can specify its prototype. You could use the object.create method to create a new object within a specified prototype, or you could directly modify the prototype. Fantastic. Class-based inheritance. JavaScript also supports classes, which provide a more familiar syntax for defining objects and inheritance. For sure. I mean, to be honest, I feel like classes make the most sense. The diagram on the right represents the prototype-based inheritance in JavaScript. Email password is a prototype of content creator profile. Like, I'm kind of just... So I'm guessing there is like a function called email password, and content creator is calling out to that function is kind of how I'm picturing it. We start by defining a generic user profile object that represents common properties shared by different profiles. We create a specialized profile called content creator profile. This profile is specific to content creators and may have additional properties. We achieve this by creating content creator profile using object.create user profile, which sets user profile as the prototype of content creator profile. Okay. So you get all those values. We add specific properties such as posts that are not inherited from the user profile. When accessing properties of content creator profile, JavaScript first checks if the property exists directly on content creator profile. If it doesn't find the property there, it looks at the prototype chain and checks if the property exists on user profile. If found, it returns the value from the prototype chain. So content creator profile inherits properties, email, and password from user profile, which also having its own unique property number of posts. This allows for a hierarchical structure where specialized profiles can inherit common properties from a generic profile while adding their specific attributes. I mean, okay. What is the default value of the age property in the user object? What was it, 21 or something? I'm trying to remember. What, 18? I gotta go all the way back to the top here. 25. What is the output once we run regular user.greet after executing the prototype code snippet? Okay, regular user.greet. Right here. And it was calling this hello regular user. Hello. Hello, I am what? Hello, Ben S. Oh boy, the great scroll. Hello, Ben S. After executing the inheritance code snippet, what is the total number of user-defined properties in the content creator profile object? Content creator profile equals object.createUser. I feel like it's 3. Did I see it up here? I think it was at the very bottom. Sorry if I'm giving any of you guys motion sickness for my scrolling. I'm sorry. I gotta keep scrolling though. Content creator profile. Content creator profile equals object.createUser. I don't know why I'm getting stuck on that. Content creator profile. I still can't remember it. Object.createUser. Object.createUser. Really, I just need to find that as object.createUser. Where did I see that? Oh. 4. And the reason I got 4 was because it's 4. I could have described that better, but I think we all understood. It's just 4. Okay. How it works. Okay. Now that we understand JavaScript, let's look at prototype pollution using the same social network example. Prototype pollution is a vulnerability that arises when an attacker manipulates an object's prototype, impacting all instances of the object. Okay. That's kind of cool. So I guess you're targeting it from, yeah, that's cool. In JavaScript, where prototypes facilitate inheritance, an attacker can exploit this to modify shared properties or inject malicious behavior across objects. Prototype pollution on its own might not always present a directly exploitable threat. However, its true potential for harm becomes notably pronounced when it joins with other types of vulnerabilities, such as XSS and CSRF. Let's assume we have a basic prototype for person with an introduce method. The attacker aims to manipulate the behavior of the introduce method across all instances by altering the prototype. So, okay, hi, I'm this name. Person on name equals name. Person, let Ben equal person Ben. So if we do what person dot introduce, we'd get hi, I'm Ben. Okay, what if an attack, I'm just gonna write this. This is like very easy to understand and really describes prototypes very well. I actually have to type this, so bear with me as I'm just gonna pause the video. What if an attacker injects malicious content into the introduce method for all instances using the proto property? In JavaScript, the proto property is a common way to access the prototype of an object, essentially pointing to the object from which it inherits properties and methods. Let's see somehow the attacker executes the following code using any attack vector like cross-cell scripting or cross-site scripting or CSRF, client-side request forgery. So ben.proto introduce equals function console.log. You've been hacked. I'm Bob. Oh, did he just change the function? But anyway, let's copy that. Prototype definitions. The person prototype is initially defined with a harmless introduce method introducing the person. Yes, it did. Object instantiation. An instance of person is created with the name Ben. Let Ben equals person Ben. Did I show the source code? No, super quickly show the source code. We have the prototype, which just has this function here that says return hi, I'm this name. We have the, I guess, what is that, the class? The function person name, the parameter of a name, let person equals object.create person prototype, obviously creating that, person.name equals name, return person, and then let Ben equals person Ben. So Ben is the variable and it's calling out to this, and the name is obviously Ben. Okay, so object prototype pollution attack. The attacker injects a malicious payload into the prototype's introduce method, changing its behavior to display a harmful message. We've polluted the prototype property here. Impact on existing instances. As a result, even the existing instance Ben is affected, and calling Ben.introduce now outputs the attacker's injected message. I would show it, but I'm not allowed to paste here. And I tried to type it, but didn't work. After executing the above code, if you try to create a new person, what would be the output of Josh.introduce? So I'm guessing it's been infected. The introduce statement, or not the introduce statement, rather the introduce prototype is infected. So that is crazy. How do you patch that? What is the payload? You've been hacked. I'm Bob. Bob. What is the name of the property that the attacker polluted? Oh, proto. Let's see what notes I can find real quick. This is a key note. Even the existing instance of Ben. So he actually poisoned the proto property, rather. Wow. So we got some cross-site scripting here. As we know, numerous properties are inherently present on the object prototype in JavaScript. Among these, the constructor and proto properties stand out as particularly notable targets for exploitation by threat actors. Oh, okay. The constructor property points to the function that constructs an object prototype, while proto is a reference to the prototype object that the current object directly inherits from. Malicious actors often exploit these properties to manipulate an object prototype chain, potentially leading to prototype pollution. The concept hinges on an attacker's ability to influence certain key parameters, such as x and val, in expressions akin to person xy equals val. Suppose an attacker assigns proto to x. In that case, the attribute identified by y is universally set across all objects sharing the same class as the object with the value denoted by val. In a more intricate scenario, when an attacker has control over x, y, and val in a structure like xyz equals val, assigning x as constructor and y as prototype, leads to a new property defined by z being established across all objects in the application with the assigned val. This latter approach necessitates a more complex arrangement of object properties, making it less prevalent in practice. Yeah, I don't know what the hell that means. Few important functions. When identifying potential prototype pollution vulnerabilities, penetration testers should focus on commonly used vector functions susceptible to prototype pollution. A thorough examination of how an application handles object manipulation is crucial. We will understand a few important functions that an attacker can exploit, and then we will practically perform the exploitation. Okay, functions that set object properties based on a given path, like object ABC equals value, can be dangerous if the path components are controlled by user input. Okay, these functions should be inspected to ensure they don't inadvertently modify the object's prototype, considering an endpoint that allows users to update reviews about any friend. Before any updates are made, we have an initial friends array containing an object representing a friend's profile. Each profile object includes properties such as ID, name, reviews, and albums. Oh. That's the XYZ. The user wants to add a review for their friend. They provide a payload containing the path where the review should be added, reviews.content, and the review content. Script, alert, any content. That's fun. An attacker updates the path to target the prototype. Path, reviews, 0.content. Okay. So obviously this is just URL encoded to get those keys added. We use the set function from Lodash to apply the payload and add the review contents to the specified path within the object. After executing the code, the friends array will be modified to include the user's review. However, due to lack of proper input validation, the review content provided by the user was directly added to the profile object without proper sanitation. And you can see it, yeah, script alert. Wow, you're able to... Oh, is that what it means by this is clearly not static, it's dynamic. So you could always add onto these arrays. Wow. Similarly, suppose an attacker wants to insert a malicious property, like is admin, you set it to true. After executing the code, the friends array will be modified to include the malicious property is admin in the friends profile. The friends object will have the following structure. Wow. Now we are going to practice. Okay, let's practice. Why am I even doing this? I don't need to go on my terminal. I just... Brain frozen. Brain smooth. Okay, we're gonna log in with the following credentials. Bob. Welcome to the social network. I love this site. Oh my goodness. Sabalenka. To identify a prototype pollution, we'll explore different functionalities of the social media app, like adding albums, setting friend requests, adding reviews, etc. Once you log in, other friends can be added to your friends list. Visit any friend's profile, let's say Sabalenka in this case. Once you visit the page, you'll see different options like adding a review, cloning an album, etc. Let's explore the submit a review feature. Okay, so let's explore the client-side and server-side code to analyze various exploitation possibilities. Now, how am I supposed to actually read that when I have to scroll? I need to put this in something that's, I don't even know, text editor. What am I doing right now? Oh my god. Oh, my brain. It's smooth. So smooth. Alright, what does this say? No. Is my big head in the way? Hey, my big head's in the way. Alright. Can I make that? I can't really make it any bigger. Okay, let's do that. Okay, so I can't believe I copy and pasted just for this. So, access submit friend review. Visit H2 class with submit review, input type, friend ID, value 1, text area, name, review content, placeholder, write your review here, rows, text area. Why did I need to see this? Is it... Oh, takes the review as an input and calls the API endpoint to add a review with the hidden parameter friend ID. I did see friend ID. Prototype evolution alone is rarely exploitable. However, once combined with other attack factors like cross-site scripting, it can provide a better attack surface. Now let's go through the server-side code. Okay, so this was on the server side. Friends, Sabalenka, app.post, submit friend review. Res, I don't know what that means, but I'm sure I can understand it. If rec session user returns, okay, if you don't have a session, I got it. Const friend ID review content equals body. What is rec? What is rec here? It's not even shown in the definition. Friends dot find. I don't know what some of this is. This is shorthand, isn't it? What is this? Often referred to as fat arrow. I'll remember that one. Oh. Let function equals parameter 1, parameter 2 expression. This defines a function that takes param1 and param2, evaluates expression, and implicitly returns its result with a single parameter, parentheses optional. Okay. It's just taking two parameters and doing something with it. So that's the parameter. And this is doing something. That's the expression. Parse int friend ID. Okay. And I guess this is where it gets exploitable, is review content, set friend, input path, payload value. Oh. I guess he wrote this. so it's easy to explain. First, it validates the logged in user session. If not, it redirects to the login page. Obviously, then the code extracts the parameter and validates the connection between the signed user and the friend ID received. The code uses the .set function in the low-dash utility that allows you to set the value of a property at a given path of an object. It's a convenient way to set values on objects deeply without having to check if each level of the path exists. If a portion of the path does not exist, it'll create it. The code analysis shows this a prime opportunity to perform the property definition by path attack. Sabalanka is extremely proficient in C++. Yes. The code doesn't even work. What are you doing? I wonder if it's because I poisoned it. I might have poisoned it. Ooh, I might have to terminate the room. I broke the room. I broke the room. What is going on with the... Oh, it's the attack box. Dude, I cannot copy and paste into the attack box? Oh, I have to do something. Clipboard. And then... What? There we go. I'm up! The world's greatest hacker in the world! Oh my god! Ludash! In the case of an expression like test ij, what would be the controllable parameter that may lead to prototype pollution I? Thank you. Thank you, everyone. Thank you. I'm a beast. I'm gonna wrap for today, but I'm probably gonna finish this room. I don't know if I'll finish this today, but maybe I'll do it tomorrow. I don't know. But thank you guys for watching. Always a pleasure. Catch you later. I don't know what I'm doing. Bye.